So today we're going to talk about one of my favorite subjects, actually, which is how can we help you get to faster incident response with AI. Before we get to that, let's just do a quick introduction. So my name is Doris Sasson, like you heard. I'm a product manager on New Relic AI group. I had recently joined New Relic as part of the Signify acquisition. But I can already tell you that I've been nerding around with data for a while. Cool. We have a technical. Yeah, that's what I wanted. I can also tell you, so this is Tel Aviv, by the way. I don't know if you ever get to see the skyline of Tel Aviv, Israel. I can also tell you that many folks in the AIOps group are based in Tel Aviv, working on AI product, including myself. And Tel Aviv is known as a city that never sleeps and a city that never stops. And much like you, busy SREs, DevOps, you never sleep. And why do you never sleep? You never sleep because your business is trusting you to always have your software up and running. Your software is your business, and that means that downtime is no longer an option for you. Well, you may not know this, but this is Tel Aviv today, right now. Tel Aviv is in downtime. Tel Aviv is unavailable. And reason why is because they have a scheduled production maintenance, if you want. It's called Yom Kippur. And once a year, the city stops. But the thing is that users don't stop on downtime. As you can see in the picture, whenever you have downtime, your users are looking for alternatives. They're finding another way. They're not waiting for the service to get back up. And the reason why users don't wait is because your users have higher expectations than ever they had before. They are not waiting for you to get back on service, and that means that your ability to quickly understand and resolve incidents in production can determine anything for you, everything for you. But the thing is that your job of keeping uptime is getting more and more complex. Why is it getting more complex? Is because you have too much data to monitor. You have many, many dashboards that you need to watch. Many, many alerts are coming in. And it's getting harder to keep pace and troubleshoot and quickly triage and understand what is the cause of the incident that we're now having, who should be part of that mitigation process, how do we make sure it never happens again. But the thing about detection and humans in general, I mean, we're all humans, we're all experts, but we're all humans. And as humans, we do detection and monitoring in three main patterns. We set thresholds based on what we known or past experiences that we had. We leverage data and statistics to do our job and understand what is going on. And we need to intentionally activate our brain and think and go into this investigation mode and try to figure out what is going on. In his book, Thinking Fast and Slow, Professor Daniel Kahneman called this state of mind activating your system 2. That system that it is proven by science that requires more energy from your body. It needs more of you. And that essentially costs time and energy. So the thing is that since we're all humans, we are all vulnerable to alert fatigue. And alert fatigue is real. It's a real pain. And how do I know that? I know that because many of our early beta customers were suffering from alert fatigue, and we saw their data, and we saw that they had that problem. They had too many alerts, too many were not prioritized, too many are not actionable. They were spinning cycles on trying to determine what they should do and finding what is the problem and how can they deal with the bunch of alerts that they are now getting. I believe that many of you are still dealing with the same problem on a daily basis. So the thing is that the world of SRE, our world, is all about fast response. So alert fatigue is a big deal. It's a big deal. It's the negative. It's the opposite of time to resolve. It's the opposite of getting to uptime. Alert fatigue prolongs your time to resolve and is hurting your software reliability. And your software reliability is a function between your time to resolve and your time between failures. And with New Relic AI, we want to help you reduce your alert fatigue and cut your time to resolve. How do we want to do that? We want to help you to take down the time it takes to detect incidents. We want to help you to cut down the time it takes to understand them, mitigate them, and basically improve your MTTRs. So how do we get faster incident response? We leverage what's feasible in the AI and machine learning practices and whatever the technology allows, and we decide and determine what is the product that we should be building to help you get there. There are many, many things that machines can now do for you and can do with your data. What we ask and what we care about most is what machines should be doing for you with your data. And like you can see, and you probably heard, there are many buzzwords around there right now. Whether it's NLP, whether it's statistical analysis, there are many, many things that machines can do for you. But the question is what they should be doing for you. And the answer is augmenting you. And this is very important. When we say AI, and when you say New Relic AI, we mean applied intelligence, not artificial intelligence. And the reason why we differentiate and we use this different term is because we, unlike artificial intelligence, we are applying intelligence, and we do not mean replacing you. It's all about empowering you and augmenting you. Because what we know is you are best at leveraging tribal knowledge and expertise, and you know best your environment, and you can circle that knowledge back into automation process, into triaging, into resolving problems. What we should be doing is helping you to do exactly that. So that all sounds really great, right? Sounds cool, AI, machine learning, we get it. You're in, you're listening to me. But the thing is that according to Gartner, by 2023, 40% of infrastructure and operation teams, 40% of infrastructure and operation teams will use AI augmented automation in large enterprises, and resulting in really great things. By the way, 40%, that's you. However, I have recently read another survey conducted by Trace3, by the way, and they are saying that 76% of IT teams have not yet implemented an AI tech. So what is that? So I'm asking you, how many of you have actually tried AIOps? And we learned that the biggest inhibitor to achieving AIOps success is connecting to the data. Think about it for a moment. The biggest inhibitor to getting your organization to AIOps success is bringing in the data and being able to utilize and do smart things with it. Well, that makes me pretty excited. And, well, that's pretty easy, right? If the biggest inhibitor to getting your organization to AIOps success is bringing in the data, that's great that Lou said earlier today that the most powerful database, telemetry database out there, without question, is NRDB. So that means that all the relevant data for AIOps is right there. It's already there. If you're using APM or logging, or if you're using any of New Relic telemetry capabilities, your data is there. Which takes me to our game-changing approach for AI. The faster we connect to your data, the faster we get you to success. Simple as that. And we don't stop with NRDB. We don't want to stop with NRDB because we know that you have observability data and information about your stack somewhere else. Whether you're using PagerDuty to manage your incidents, whether you're using any other logging for alerts, whatever it is that you're using, as long as you have alerts on top of that, we can ingest that, and we can correlate that, and we can do smart things with that and help you succeed. So you can use our REST interface to integrate any data source and send it to New Relic AI. That's it. We know that many of you are getting work done and triaging incident on your paging solution. You're getting paged, and the first thing to do is understand what is it that is alerting, what is the problem, and then you go and start investigating. So because we know that, we choose to treat PagerDuty as an example, like an alert hub. And if PagerDuty is an alert hub, we can connect to it. We can ingest data from it in real time, and then we can correlate all the data, add additional context, and send it back to PagerDuty. That's it. So you don't need to change anything in your existing workflows. So it's not just about being so fast at connecting to the data. It's also about not making you switch context, not making you switch tools. Switching tools is costly. Switching tools requires training. And we don't want you to deal with that just to be able to use AI and machine learning. AI and machine learning should be applied to wherever you already get work done. This is how it looks like, by the way. This is a screenshot from a PagerDuty account with an alert, an incident that was correlated by New Relic AI. You can see the alert's been correlated on the left, which is my left if I look, yours left, my is the right. You can see the correlated incidents, and you can see the additional information that we added in annotations on the right. It's there. You don't need to open a new tool. You don't need to go anywhere else. So I started this conversation, this discussion, I started it about you. You are the center, you're the key to the success of your organization. And it's not me saying that. It's there, it's a fact. Your job determines how your business performs, and high-performing organizations are successful organizations. So with New Relic AI, we want to augment and help you with every step of your day, every step of the way. So whatever, if you need to configure or detect or refine and assign or respond or retrospect, we want to provide value. Let's start breaking it down. We started with this, and we can see that time to detect is usually measured by the time it takes from the root cause, something happened in production, to the time you know that it happened, that it was detected. And we want to help you reduce that time. So how do we do that? We do that by building and implementing what we call actionable detection. The thing about detection is that you can use machine learning to find anomalies. Anomaly detection is there. It's been there for a while. But what usually happens is that you then get detection for the sake of detections. It's just more alerts. And that's just more noise. You need to have that every detection means that every single time we detect something, we want it to be actionable. So here's two examples of two great features that we introduced in the past. And I want to reiterate on them today, because they are just great. What we see here is incident context, which means that whenever you get an alert, you're already getting anomalous behaviors upstream, downstream. So you can tell, and you can start your understanding a lot faster. You can just look and see, OK, so I have this entity alerting, but upstream, there's some anomalous behavior. Maybe the problem is there. I can just start looking. I don't need to start wandering around to understand what is wrong. Here we can see what we call automatic profiling. So it's not enough to get an alert. I want to know things such as the frequency of the alerts. How many entities are currently having the same alert? All these things provide context, and they are actionable, and they help me reduce the time to detect. So the thing is that similarly to PagerDuty, you get a lot of your triaging work, a lot of the phase where you're starting to figure out what to do with the alert, you do that in your collaboration tools. Take Slack, for example. You get an alert, you jump on a channel, and everybody starts figuring it out. So if you're doing all of that and all the communication happens in Slack, and lots of teams are involved, and everybody are jumping on the alert, why not bring that information and context into Slack? So that's exactly what we want to do. And today we're announcing failure modes, real-time failure mode detection in private beta delivered within your Slack. So the things with failure modes is, let's say that, I'm going to show you how it looks like. So, well, I don't have it here. But the thing, I'm going to talk about this feature in a minute. But the things about failure mode is, let's say you have application that you don't have alerts set for it yet. You didn't set the conditions. It happens all the time. But you still want to know if something goes off. You still want to know about it. So what do? With failure mode, you're able to choose those services and applications that you care about. And whenever something anomalous happens, we do that by measuring baselines. Whenever something anomalous happens, we let you know. But not only that, if there was a deployment that happened around the time that the anomalous behavior was detected, we add that information directly within Slack. So you don't need to open another tool, another page, anywhere else. It's there in Slack. If you don't believe me, come visit in the booth. We'll show you how it looks like. The second thing that we see here is your incident context, such this time in Slack. Whenever you're going to get an incident that we found anomalous behavior on the upstream, downstream, it's going to be added automatically to the alert in Slack. That's in GA. You don't need to do anything about that. It's there. Moving on. Let's cut time to resolve. So that's probably the most painful metric, success metric for all of us, right? How do we cut time to resolve? So with New Relic AI, we're introducing in private beta our correlation engine. And the idea is to reduce noise and help you with alert fatigue. And how we do it. So the question you may ask yourself is, what are correlations? Why should I care about correlations? Why correlations matter? So basically, correlations are being able to look on different incidents and alerts across your stack and find meaningful relationship between them. And when those relationships are found, we merge them together. That means that instead of getting 16, 20, sometimes even 100 alerts, you're getting one single page, and that's it. In addition to that, we add all the context and the relevant information to support that, to explain you why it was correlated and why and what you can do with it. This is the system overview, the pipeline, if you will, of New Relic AI and of the correlation engine. What you can see is that we ingest data from New Relic violations or from PagerDuty or via REST from any other data source. And then we normalize the data. So we're able to analyze it regardless to where it came from. And after we normalize the data, we enrich it. We run machine learning models that I'm going to talk about in a minute to add more information to the original incident. So we can later on utilize it for more things, such as the correlations. But not only. After that, we start managing the lifecycle of the issue. We prioritize it, we aggregate it, we group different incidents. And we also run suppression, which means, I don't know if it ever occurred to you that you woke up in the middle of the night, you're getting a page, you look at your mobile, you look at the incident, and you could swear that this page, this alert, is going to resolve itself in the next 30 seconds. So you're not going to do anything about it. So we're asking, why to even page you in the first place? Why not just suppress the incident and let it resolve on its own? And that's exactly what we're doing. Cool. Let's talk about the correlation itself. So correlation sounds great. Told you all about it. You're already in. How does this thing continually improve? How does this thing not stay static? So we find that there are two great ways to improve correlations and to improve the logic. One is using human knowledge, user actions, user feedback. And the other is the data itself. If I ran a correlation and it provided value, I can evaluate it, and I can analyze the data, and I can decide if I can continually run it or maybe to deactivate it. And it happens automatically, and it's self-sufficiently, and you don't need to do anything about it. But we still want you to be in control. We still want you to be able to influence the logic. So we take your user feedback very seriously, and we circle it back to the engine. So that's exactly what we call feedback loop. So feedback loop is a big thing in data science. And it's a very important piece because it allows the machine to improve and to learn and to train, basically. So the thing is that we find two different ways to improve and to help the machine continuously improve. One is we call it suggested decision. Suggested decisions is, I don't know if that's, I love that analogy, but let's talk about Netflix, for example. You're getting recommendations for things that you've watched in the past, and now you're getting recommendations for new things that you might be interested to watch. Same thing goes with suggested decisions. We saw your data. We saw certain events happening in the same time window, and they had mutual relevant content data or metadata that was relevant for correlation, to get together, to be grouped. Fine. So we suggest to you new decisions, and we allow you as a user to activate or deactivate them. So that helps the system to continually improve and provide better noise reduction. And the second part is the decision analysis, which is if the decision is running, we can simulate and evaluate it and see what is the potential noise reduction. And if it's not getting better, or if it's remains static, maybe we can do something about it, maybe improve the logic, maybe do something else. Cool. But most importantly, there's you, the user feedback. This is how the UI of New Relic AI looks right now in NR1. I love it, by the way. Lots of thought was invested in that. And the reason why is because we want you to be engaged with it, and we want you to be able to provide feedback in a way that doesn't require a lot of energy. So you can simply just click on it and say, this correlation event was helpful or it wasn't, and we circle it back. Let's talk about understanding. So this is, I would say that this is the most critical part. You already got an alert. You're already in investigation mode. How do I understand faster? How do I get the answer faster? So we're introducing two different features that can help you with understanding. The first one is, we call it suggested responder. The great thing about a suggested responder is that we look on your historical data, your historical PagerDuty data, and we say, for any new net new incident, who should be on that incident? Who should be assigned to it? And we suggest to you that. So that means that every time you get an incident, you will get the suggested responder for that incident. So you don't need to start looking around and thinking, I don't remember who was the one that was dealing with it last time. No, that's it. It's there. It's the annotations. You see that. You just assign it to them, or you delegate to them, and that's it. And it's all based on machine learning models, and it's out of this world. The second thing is alert classification. This is where things really get wicked. So the thing is, we're ingesting data from very, very different data sources. Schemas are different. The content and metadata is different. So how do you classify them? How can you tell if the problem is error, or traffic, or saturation, or latency? So we run machine learning models that are able to classify that into the 4 signals. And we enrich the original incident, and it's part of the correlated issue. So now we can correlate per golden signals. Or now we can route information back per the golden signals. And that's it. So if you care only about latency, that's the thing for your team. You only care about latency. That's what you're currently worried about. You can route only latency information to wherever you want. Great. So that's obviously helping also with understanding the underlying components as well. So the thing we do is not only look at the golden signal, we're also breaking it down to the related components. So that could be database, web service, API, Then when you have the related components, you could do the exactly same thing. You can correlate using that. You can route using that. All that great things. And the result, well, I would probably click another one. Yeah. So if you look at the issue page, again, this is NR1, available in private beta today. You can see that this issue, for example, was analyzed into an error, and the related component is database. And guess what? You can also provide feedback on that as well. Talking about the correlations. All right, and the last thing is time between failures. So time between failures is a tricky part because there are many, many things that can define and influence if you're getting another failure, if another thing breaks. So how can we help you improve that? We look at what we call continuous improvement, and we look at your knowledge. We want to help you put your knowledge and team expertise to work. So basically, that means that whenever you do something, for example, if you mitigated a problem and you retrospect and you captured information, we want to use that information in context. So let's say the next time something breaks, and it's very similar to a problem that you already resolved, why not surface the retrospect and the postmortem in the context of the new incident? So that's one thing. But not only that, you can provide feedback, you can engage with many, many aspects of New Relic AI, and we use that to circulate back and improve the system. So to summarize, New Relic AI is the first product that is taking an approach that I would say is hybrid. It tries to utilize both your knowledge and expertise and your user information, user action, and feedback, but also automatically and self-sufficiently improve based on data and analysis. Beside that, we want to be the fastest to connect into the data. Because like we learned and like we understand, getting faster into the data is the key to getting your AI success. And it syncs and it delivers to your existing workflows. So you don't need to switch context. You don't need to train new workflows, new tool chains, none of that. Thank you for listening. Please come visit us in our booth, and we'll show you how it works, show you how you can integrate, and show you how fast it is. Thank you.